Good morning all. Welcome to the lab session of lab practice 1. Today we are going to learn about assignment number 3 on artificial intelligence and robotics. Problem statement for today's practical is use of heuristic search techniques to implement best first search. Learning objective is to understand the informal search method based on heuristic search techniques. Learning outcomes, student will be able to understand best first search method for graph traversal. It will help to find out optimal path for the from source to destination in graph. Basics of best first search. Best first search traversal is a traversal technique that decide which node is to be visited next by checking which node is the most promising one and then check it. For this, it uses an evaluation method to decide the traversal. This best first search technique of tree traversal comes under the category of heuristic search or informed search technique. The cost of nodes is stored in priority queue. That means for the implementation of best first search, we have to implement the priority queue concept of data structure. So methods for implementing the best first search. First step, we have to create a priority queue and we have to insert start node in the priority queue and we have to visit each node by deleting the element from the priority queue. If the element is a goal, means we have reached a destination, then this method will exist. Otherwise, we have to traverse, search each and every neighbor and we have to mark as a examine. Until and unless we are not visiting all the nodes, step third is executing in iteration. Now let's demonstrate best first search with example. Consider the below search problem. We will traverse it using the best first search. So this is a tree having the starting node yes and number of intermediate nodes, and at each iteration each node is expanded using evaluation function f of n is equal to h of n. In this table they have given value of h of n for each node. So now expand the node yes means visit the first node yes starting node and put in a closed list. In the best first search we have to maintain two lists, open list and closed list. So yes node is examined, that node is kept in a closed list and the neighboring node of the yes are kept in a open list. So initialization, so node which have visited which have examined is kept in a closed list and then their respective children's a and b are kept in a open list. Now I will compare the value of h of n at node a and at node b. Value of h of n at node a is 12 and the value of h of n at node b is 4. Out of this 4 is minimum. So from open list, B will move to the closed list. From open list in iteration 1, that B node will move to the closed list because this has the minimum h of n value. And iteration 2, respective nodes of B, E and F are kept in a open list. Now I will compare h of n value at node E and at node F. So h of n value at E is 8 and at F is 2. Now, out of that 2 is the minimum. So, F from the open list will move to the closed list in iteration 2. Then the respective children of node F, I and G in iteration 3rd will kept in a open list. Then value of H of n at I is 9 and at G is 0. Out of this 0 is minimum. So, G will come to the closed list at the end of iteration 3. And once we reach to the destination node, we will stop our execution and whatever the elements in a closed list is the path from source to destination. Hence, final solution path will be starting node yes, will visit first node B, then visit node F and then final node G. This is the basics of best first search with example. Let's demonstrate the implementation of best first search in C++. For that we have to open IDE for writing the C++ code. So let's open the IDE. This is the IDE for C++ code. In C++ we have to first include the header file. So hash include bits slash std c++ .h. This file we have to import for the best first search. Then first line in C++ is using namespace std semicolon. Then we have to initialize two variable, two user defined data types by the keyword type def. Name is pair having two integers, int comma int, and name is pi. Then we have to declare one vector to store all the values of node of the graph. So vector is like array like structure, name pi, and I will give that vector name as a graph because it will store all the node values of that graph. Then I will write the function for the main, int main. So int means I will declare the one variable int v is equal to 14. That 14 is the number of nodes of the graph. Then I will define the size of the graph. Graph dot resize. It will define the size of the graph equal to v, means there are the 14 number of nodes in graph. Then we have to add each edge in a graph from one node to the other node by the function add edge. Add edge is a function to add the edge from one node to the other node with the cost. So add edge has the three parameters: 0, 1, 3. So here first parameter 0 is the first node, then 1 is the second node, means there is the edge from node 0 to node 1 having cost 3. Now same you have to for the add edge 0, 2, 6. There is edge from node 0 to node 2 with the cost 6. And we have to copy this function for all respective edges. So here copy paste all this sentence. There is the edge from node 0 to 3 with the cost 5. Then there is the edge from node 0 to node 4 by the cost 9. There is the edge from node 1 to 5 with the cost 8. There is again edge from node 1 to the node 2 to the 6 with the cost 12. Then from node 2 to 7 having cost 14. That just like we have to add edges for each node. So from node edge from 3 to 8 having cost is 7. Then edge from 8 to 9 with cost 5, with edge from node 8 to 10 with the cost 6. Then edge from node 9 to 11 with 1 cost 1. The last is edge from 9 to last node 13 with the cost 2. So these all edges we have added in our graph from one node to the other node. So now we have to find the path from source node. So int source node is a 0. The source node is a root node, and we have to find the path up to the node 9. So int target is equal to 9, means we have to find optimal path from node 0 to node 9. So for that I will implement the function. That function name is best underscore first underscore search. This function we have to call, pass the parameter source comma, target, and comma v. V is a number of nodes we have to visit. So return 0 because main function having the integer. So return 0. Now write down the code for the function add age first. You have to write down the code for the add age first. Now function for the adding the age. So void add age having the three parameters. Integer x means one node. Integer y means second node, means age from x to y with the cost, integer cost. Open bracket and close bracket. Then we have to add this age into the graph. The graph is a vector. So graph of x is equal to dot push underscore back all these functions from the header file bit slash std.h. Make pair with cost and y, means x is a pair with y and then y is a pair with the x. So I will copy this sentence for the y. So graph of here just instead of x replaced by the y and y replaced by the x. Now this is a function to add the age from node x to node y. Then now I will write the function. Then I will write the function for best first search. So void best underscore first underscore search. This function we have called from the main function. So parameter is integer source node, comma integer target and integer n. Then here open bracket and close bracket for the best first search method. Then we have to first declare the vector of type boolean to mark node is visited or not. So visited name is visited with the pair n comma false. Whether this node is visited or not. If the node is visited, it will true. If not visited, then false. Initially value is false because initially all the nodes are not visited. And now declare one priority queue. So priority underscore queue with the pair pi and vector pi. It will maintain the list of examined node and visited node. Then pq dot push make pair underscore pair 0 and source. If they having the direct link, then we have to push to the priority queue. The next line visited is equal to true. Once we have visited the node, we have to make it the equal to true. And then while loop until and unless queue is not empty. So queue is not empty. PQ priority queue is not empty. This while loop will execute. Int x is equal to PQ dot top, and here we have to display the path count cout x. So it will display the first visited node with the minimum cost, then PQ pop means we have to remove that node from open list to the closed list. That's why here pop. And if x equal to target means once we reach to our goal, then it will break the loop. Else we have to visit all its neighbor. For loop I equal to 0, I less than graph of x of I. It is a vector means source and destination comma I plus plus. And if not visited, then we have to visit. If not visited, graph, not visited graph of age x and y. We have to put in a visited list. So here visited of graph x of I. Now this is a complete code for the best first search. To compile this code, we have to press F9, and to execute this code, we have to press F10. So I will press the F10 to execute this code. Then I will get the output as the optimal path from source to destination. Let's see the output of this code. So after the execution of this code, this is the output. Path from source node 0 to destination is, first it will visit the node 1, then node 3, then node 2, then node 8, then node 9. So this path will give the minimum cost. So this is the implementation of best first search using heuristic search method. It will obtain the h of n function, heuristic values for each node, and get the minimum cost of the path. Thank you all. I hope you have understood the concept of best first search with heuristic search. Thank you all.